estimating a population variance of what? Of population. But we cannot, as we say, that it's expensive to deal with a huge population. So alternatively, in statistics, we draw the sample and then we do estimates for using the drawn sample, and we confirm that the actual value of the populations will be like that, right? So we go back to, okay, from a population whose variance is unknown. Suppose, so let me teach you the concept first, the derivation of the formula. Suppose that we have a sample. We have a sample of x1, x2, x3, xn, drawn from the population. From the population whose variance, which is this denotation, is what? Unknown. So whose variance is unknown. So then we want to determine the variance using the sample data. So we say that we can estimate, the topic is called the statistic estimation. We can estimate the population variance by using the sample data accurately. Okay? There's a sample data accurately. So how do we estimate? So then we come to the next part, the derivation of the formula. Derivation of the formula estimate variance. Okay, so let us derive the formula estimate variance. Okay, so in this case, we say that we can deal with variance, and we deal with it differently. We say I will be following some steps. The first step, we say that recall the formula of variance, where variance of ungrouped data. Where did we learn it? Ungrouped data. Where did we learn it? During our A-level studies, or even during our ordinary secondary education, or during our ordinary diploma. So how did we find variance of ungrouped data? So it's a variance of ungrouped data we used to find it by taking summation of deviation, square of deviation, from the first deviation to the last deviation, then divided by what? By the total number of statistical data. So this is the general formula, right? But we can clarify, we can simplify that formula, but we told you that deviation is equal to statistical value x minus what? Assumed mean. So this is the symbol for assumed mean. But for this case now, deviation for this case will be equal to statistical data xi minus assumed mean, which is mean of 40, mean of population, right? So you say that if that's the case now, you say variance is equal to what? is equal to summation of statistical data minus assumed mean square divided by from I is equal to 1 to n divided by n. So suppose that this is the first equation. So the second step, we say that the statistical variance, which you call TS square, right? Statistical variance of the sample is given, of the sample is finite, of the sample drawn from what? From the finite population. The sample drawn from the finite population. So that once, we used to say that the statistical variance, which is S square, is equal to summation, or no, we say that this is given as what? The fractions, which is sample size of a sample size minus 1, and then we multiply by population variance, which is sigma square. So suppose that this is equation 2, right? So that's the case, that's the equation 2. Then we go for the third step. The third step, we say that there's a relationship between equation 2 and the equation 1. So it means that equation 1 is a subset of equation 2. So we say that substitute equation 1 into equation 2. And that's how mathematics is beautiful. So it says statistical variance is equal to sample size over sample size minus 1, and then times what? Population variance. For that case, we say that there it is summation from I is equal to 1 of x minus mean square, and then we say that divided by what? Divided by sample size. And this one we simplify. So we find that the statistical variance, which is the estimated variance of the sample from I is equal to 1 to n, this one from xi minus mean square, so we divide with sorting, so we divide with sample size minus 1. So this is our final, or the formula that we use to find the point estimate of what? Of variance of statistical data. So that's the formula, right? Simple, it's not complicated, the formula. You just have to remember these two formulas. First equation, the second equation, that's all. Well, so in case you didn't understand any points concerned about that derivation, please let me know in the comment section so that I can help you as well as I can. Okay? Or as well as the Lord enable me to help you. So then we have an example. That is example 4. So we have example 4. And this example 4, it has 2 parts, part A, part 3 parts, part A, part B, part C. And then I'll leave the homework for you, because now you are expert in this stuff. So the example 4 states that in a sample of fire measurement, in a sample of fire measurement, sample fire measurements, the diameter of a sphere was recorded by the scientist as 6.3, this diameter of the sphere, and also the other one is 6.36, and the other one is 6.37, and then 6.32 and 6.37. 6.37 centimeter. Determine unbiased and efficient estimates of Roman A, the true mean, Roman B, the true variance, and Roman C, the standard deviation of 40 of mean, so SD. Okay. So the unbiased and the efficient estimate of the mean is equal to the population's mean. Okay? So that the question is not a one question like example 2 or like example 3. This is a little bit, it is a short question. You can also solve it. So the question says, in a sample of fire measurements, the diameter of the sphere was recorded by a scientist as 6.33, 6.36, 6.37, 6.32, and 6.37 centimeter. Determine unbiased and efficient estimates of the true mean, the true variance, and the standard deviation. So solution. Hence I will leave homework to be the end of this lecture 2. Okay. So then the first step, we have to find the true mean. The true means that the mean, we call it the true mean is sampling distributions of mean. The means of sampling distributions of what? Of mean. So you say that Roman A, the true mean, okay, so the true mean, this is mean of sampling distributions of means, and I have already taught you, okay, at the beginning of this lecture, which this is given as xi is equal to I is equal to 1 to n over a sample size, which is n. So it means we say that the true mean for this case is equal to the given statistical data. So we have 6.33 plus 6.36 plus 6.37, then plus 6.32, then plus 6.37, divided by, how many are there? 1, 2, 3, 4, 5. So 5, that. So if you use your scientific calculator, the average will be 6.35. So the statistical mean is equal to 6.35 centimeter, because the dimension means that the unit, because this is the magnitude and then this is the unit. So the unit of each statistical data is in centimeter, because it's the diameter of the sphere. So we can conclude Roman A as the true mean, the true mean of diameter of the sphere, you can say simply 6.35 centimeter. So this is the final response. Then we go for Roman B. Roman B is the standard deviation. No, Roman B is the true variance. True variance means that it's the variance of something distributions of the means. Means that variance of the sample at the mean. So the true variance for this case, we have to remember the formula. So true variance for this case, it means that you have determined what the statistical variance. So in this case, suppose that here this is the first state. This is the first state for my R, and this is the second state. Second state, we say that it doesn't call the formula for this variance, for the statistical variance. So the statistical variance, it will be the summation of when I is equal to 1 to n, and then we say what? So you have xi minus what? Minus mean square divided by what? So divided by sample size minus 1. So then we say that, remember, this one is biased estimator. So it's equal to mean of what? Of population. So for this case, the xi will be these values at different cases. And hence the mean of populations is equal to 6.35. So even if the Roman A is not asked, you have to find the mean, because we need the value of mean in order to find this statistical variance. So we call the variance of something distributions of the means, which means that variance of the sample, the true sample. So if that's the case, we say that, just to remind you, the mean of populations of mean is 6.35. So you have to do the computation. So the steady state, after recalling the formula, so we have to compute it. You have to compute the variance, the true variance, which is S squared. How do you compute? This is the way that we compute. Variance is equal to it. So we start with, we have what? First statistical data is 6.33. So he minus his mean of what of population. The mean of population is 6.2535 square. Plus what? 10 plus what is 6.36 minus what? Minus 6.35 square. Plus what? Plus, again we have what? 6.37. 6.37 minus 6.37, 35. Is it 35 or 25? Let me just check it. Yes, 35 centimeter. So this one is square. Then plus the next data is 6.32. 6.32 minus 6.35 square. Then we plus. The plus is what? 6.37. 6.37 minus what? 6.35 square. And then all of this addition, we divide with how many data do we have there? We have 5. So 5 minus 1. So use your scientific calculator to compute the value of 40 of 2 mean. Compute the value of 2 mean. So the value of 2 mean, which is S squared, will be, for your computation, you'll find that is 0.055 centimeter. but this will be centimeter square. Hopefully, yes, centimeter square. So then, conclusion for man B, we say that the true mean is 0.00055 centimeter square. So you go for man C. Questions asked as a standard deviation, or we call it the true standard deviations, can call it. So for man C, it will be the first step. So we say that we call the formula. We say that the standard deviation required there, this will be equal to square root of the statistical variance. So standard deviation, which is this one, or you can call it just S for this case, is equal to the square root of what? 0.0055 centimeter square. And then the value for standard deviation will be 0.0234. 0.0234 by using your scientific calculator. So simply say that the standard deviation or the standard error is 0.0234. Let me write it clearly. The standard deviation or the standard error is 0.0234. Centimeter. Okay, if that's the case now, thank you very much for joining me in this fantastic, exceptional lecture. Now I would like to leave the homework, because in order to test you whether you have understood what I've been teaching you from the beginnings to this point, I have to leave a homework for you. So right now it's the time for homework 3, homework 2, right? And this homework 2, we regard this as example 5. So let me give you the simplest question. A random sample of 9 electronic components. Interesting. I like electronics components. 9 electronics components, right? Produced by a certain apartment. Produced by a certain apartment. Produced by a certain apartment. No, a certain company, excuse me. Sorry. It's not apartment, but a certain company. Right? Certain company. Okay, certain company yields the following sizes. Yield the following sizes. Okay, yield the following sizes in suitable units. Suitable units. We have 12, 1,211, 1,204, 1,187, 1,208, we have 1,220, We have 1,216. We have 1,213. We have 1,198. We have 1,197. What are the estimates? What are the estimates? What are the estimates of the population? Of the population standard deviation and the population variance. And the population variance. And the population variance are the question that we have. So let me read clearly, in case that maybe you don't see these words clearly. A random sample of 9 electronic components produced by a certain company yields the following sizes in suitable units: 1,211, 1,204, 1,197, 1,208, 1,220, 1,216, 1,213, 1,198, 1,197. What are the estimates of the population standard deviation and the population variance? So please make sure that you solve this question and let me know your finding or your response in the comment section of this video. So I thank God who have been with me. I thank God who gave you an opportunity to join me in this fantastic and unique lecture. May God bless you abundantly, and make sure that you can review this material several times as you can. This is the end of lecture 2. Please join me in lecture 3 of Statistical Estimations. Also, remember to subscribe onto this YouTube channel so that you can be informed or notified by the YouTube community as I upload a new video. So thank you very much. This is Olenjolaim from United Republic of Tanzania. Share these contents to other colleagues or to other students in Africa, whether in Tanzania, whether in every region or in any institution, from institution to institution, from college to college, and even share to those postgraduate students. This material may be relevant for them to review and make sure that they review the concepts of statistics and research, or the concept of statistics and probability for their research. So thank you very much. May God bless you. Stay tuned. See you in the next lecture. See you.